Okay, so are you ready to dive into something kind of crazy? We're going to explore a whole new way to think about data storage.
Yo, yeah, this is going to be a good one.
Get this. What if we didn't have hard drives or servers?
Hmm.
What if data just existed when it was moving around? You
Right.
know, you've been jotting down some thoughts about data existing only in transmission. And we found this really cool article called Data Without Storage. It's got a question mark.
Ooh, intriguing.
I know, right? It's going to blow your mind. It goes into computer science, quantum physics, even
All
neuroscience.
connected, all
I
fascinating.
know, it's wild. So, imagine a world, right, where you don't store data anywhere. It just exists when it's going from point A to point B.
It'd be a huge change.
Yeah.
Instead of hard drives or the cloud,
Uh-huh.
imagine data flowing constantly like a river.
Ooh, I like that. Like a river, but rivers aren't exactly predictable, right?
Right. Yeah.
How could we make sure that data is always there when we need it?
Good point.
Yeah.
We'd need insanely good networks, super fast, super reliable, way beyond what we have now. Everything depends on that flow being perfect.
Okay, so let's say we figure that out. What about security? If data is always moving, how do you keep it safe?
That is the million-dollar question, and that's where things get really interesting. We can look at things like quantum key distribution for some answers.
Okay, you're going to have to explain that one like I'm five. What's that, and how does it protect data in motion?
So picture this. Instead of sending information through a channel where someone could intercept it, you create a special quantum state between two parties.
Yeah.
And this state is so sensitive that any attempt to peek at it, it changes the state itself. Instantly, both sides know something's up.
So eavesdropping actually ruins the information itself. That's wild.
Exactly. And that's just one way quantum ideas can apply here. Remember, the article mentioned data as energy states? That takes us deeper into quantum territory. Imagine computers using qubits, which could be both 1 and 0 at the same time.
Whoa, wait a minute. So instead of data being a 1 or a 0 in a fixed spot, it's defined by the energy of these qubits, which are always changing.
You got it. It's not about where the data is,
Yeah.
but about this ever-shifting energy within a quantum system.
So you could have a whole network where data lives as these entangled states, zipping between qubits. It's like the information is woven into the network itself.
Right.
But if we can't pin down the data, how do we use it? How do we even find it?
That's where our own brains come in. They're surprisingly good at this.
Wait, what? Our brains? How do our brains store information differently from computers?
Think about it. Your memories aren't like files in a folder, are they?
Not really.
They're more like patterns of activity, always changing as you recall them or experience new things.
So it's the connections that matter, the pathways between all those neurons firing, not just some data point sitting there.
Exactly. The information isn't just stored, it's held within the connections themselves. A constantly changing web of relationships. It's a totally different way to think about data.
So instead of fixed data points, it's more about the connections, the signals, kind of like, I don't know, analog computing.
You're spot on. Analog computing uses these continuous signals, like the electrical impulses in our brains. It's all about flow and interaction instead of static bits.
This is blowing my mind. It's like this whole idea of data in transit is making us rethink everything about how computers work.
And it gets even wilder. The article goes on to talk about, get this DNA.
DNA, hold on, we're talking about biology now.
Yeah.
What does DNA have to do with data storage?
Think about it. We always say DNA is the blueprint of life, right?
Yeah.
But it's not just about the blueprint itself. It's about how that information is used.
Okay.
We think of DNA as this static storage thing. But the really cool stuff happens when that information is actually being accessed, when it's being expressed.
So it's not just sitting there.
Right. Cells don't use the entire DNA molecule all the time. They use RNA to pull out the specific instructions they need, right when they need them.
Whoa, efficient. So instead of storing a whole library, it's like having the exact book you need delivered to you.
Exactly. Just-in-time data. Imagine that, but for everything. Instead of storing massive data sets, we have this blueprint of data within the network
Okay.
and the actual information. It's only accessed and assembled when it's needed, just like RNA transcribing genetic code.
So we really are talking about data existing only during transmission. This is wild.
It fits in perfectly with packet switching,
Yeah.
which is already how data moves around the internet.
Right. You break a big file down into smaller packets. They all travel separately, then come back together at the end. So we're already kind of doing this packet switching thing.
Exactly. Now take that idea to the max. No more storing whole data sets.
Yeah.
Just these packets constantly flowing, only becoming usable information when they're needed, like self-assembling puzzle pieces.
So data wouldn't be tied to any single place anymore. It's just always on the move until it's needed. That's incredible.
And because these packets are constantly moving and being checked against that central blueprint we talked about,
Ah.
data loss is less of a worry. It's a way more resilient system.
Okay, so we've gone from quantum physics to brains to DNA. We're getting inspiration from everywhere. And it all points to this wild future for data, right? Oh, and the article mentions holography too. What's that all about?
Ah, holography. In the simplest terms, it's how we make those 3D images that seem to float in midair.
Right, but they're not just pictures, are they? It's not like a photograph.
Exactly.
Hmm.
Holograms don't record the image directly. They use something called wave interference patterns,
The wave interfering.
like ripples in a pond. When
Mhm.
two ripples cross, they make a unique pattern, right?
Right.
In holography, these patterns are made by light waves. Shine the right kind of light back onto it, and boom, the image comes back.
So the data isn't stored in a specific spot. It's spread out across this wave pattern.
You got it. And it can only be read when it interacts with another wave, like a specific request for that data.
So it's like the information is woven into the wave itself, just waiting to be unlocked.
Exactly. It's blurring the lines between storage and transmission completely.
Wow.
And this leads us to wave computing, using light waves or other waveforms to compute and store data at the same time. The potential is huge.
So, wow, we've gone from like quantum mechanics to brains to even the blueprints of life itself. And it seems like it all points to this like crazy dynamic future for data. But I mean, how do we actually get there? What's standing in our way?
Well, you got to remember, this is a totally different way of thinking about data.
Ah.
Our whole system now is built around storing data in one place.
Hmm.
To make this data in transit thing real, we'd have to change everything. Networks, hardware. It's a huge challenge.
Yeah, it really makes you realize how stuck we are on this idea of data just sitting somewhere, right? And what about like making sure the data is always safe and sound? Right now, we know our data is somewhere, but in this constant flow, would it be reliable?
That is the big question for sure. We're talking about a level of redundancy we've never even attempted. Multiple networks, all double-checking and fixing data on the fly. It's a massive engineering problem. But hey, not impossible, right?
It sounds like we'd need everyone on board. And speaking of things we need to figure out, what about security? If data's always moving, how do you keep it from falling into the wrong hands? It's not like you can just lock it up in a vault, right?
And that's where the really cool stuff about quantum mechanics comes in. Entanglement, quantum encryption. Imagine a network where just trying to snoop on data changes it, tipping everyone off instantly.
So security wouldn't be an add-on, it'd be baked into how the data moves.
That's amazing.
Yeah.
But okay, let's be real. This all sounds pretty far out there. Are we talking decades away, or is this closer than we think? It's funny how technology sneaks up on you. A few decades ago, the internet seemed like a sci-fi dream. But the exciting thing is, we're already seeing the pieces. Quantum computing is getting better, networks are evolving, and like we talked about, we're even learning from biology and brains. So it's not if this revolution happens, it's when.
It's like we're on the edge of a whole new relationship with information itself. It's not just about speed or efficiency. It's deeper than that, right?
Exactly. It changes everything. Instead of data being something you own, something static, it becomes this shared resource. It's alive, constantly changing and evolving as it flows between us.
It's a whole new way of looking at things, for sure. Less about owning information, more about being part of this interconnected system.
Wow. That's the amazing thing about these deep dives, right? We started with one question. Can data exist only in transit? And it's opened up all these possibilities, challenging our assumptions, pushing the boundaries of what we thought was possible.
All because we were brave enough to ask the question. And to think, we got here by exploring quantum physics, neuroscience, biology, proof that sometimes the wildest ideas come from looking outside the box. So to our listener out there, we leave you with this. What would a world where data is always on the move look like to you? How would it change how we communicate, how we work together, how we experience the world? We don't have all the answers, but one thing's for sure, it's going to be one heck of a ride.